even though I love my board. So we had question 9, which I thought, was it 9? I thought I gave a bit of a hint to that at the end of the lesson, but, you know, it was the end of the lesson, so fair enough. And 12 as well. Sorry, was it 10? So we probably focused a little bit more on angle of depression and we glossed over these, but I did put it there and make sure that you needed to have a look, and it's saved on the, I think it was saved on the OneNote. So if you think, it's not there, when you look in a minute, let me know. So the thing to remember is if you have a rhombus, the right angle obviously appears where you can see it, the diagonals cross at a 90 degree. Isosceles triangle, which is probably what we're going to use in a minute. And when I say probably, it will be, because I've done this question already. You split it down the middle and then we get our right angle. So let's have a look at the question at hand. That's not it. That's not it. That's not it. Yay! We're back. Okay, so a couple of tips when you're doing these questions. Sometimes it's easy. Label, put all your information on a diagram, and then you can get rid of any white noise. Do you know what I mean by white noise? Yeah, the extra stuff you don't need that might be confusing you at times. So first off, we go AB is a chord of a circle. That's nothing to be worried about. A chord is just from one point to another on a circle. The most special chord is the diameter. It goes through the center. All right, so it's got a radius of 5, so I can put 5 here and I can put 5 here because they've got to be the same. And as soon as we realize that they're the same, we realize, hello, it's an isosceles triangle, right? And what else do we know? We will eventually cut it in half, but what else do we know? Yeah, AB is 8. Excellent. Now, this stumped some of the people in the other class, and that's good that we solved some of these issues. Find the size of, now this is basically just saying, what's it saying? You don't know because you're talking. So can we pay attention? You are on video now. Right, the size of, this is angle AOB. So AOB. I tend to write it angle AOB. But you're wanting to find this angle. All right, it's got the little hat over the angle that's required. Both methods are okay with asking for that. Does that make sense? So for me, I'm just going to go, okay, I'm looking at that. As Carolyn said, I can make it go down in the middle, and that's where my right angle appears. You can keep it as the same sort of thing if you want. I'm just going to look at it like this. I'm going to go, that's 5. What's this length? 4. Very good. Not 8, but 4. Yes?
So don't we know that one of them has to be 3 because it equals...
Well, sure. It's well done for noticing that, right? It's a 3, 4, 5 Pythag triangle. But what is it that we're asking to be found? This angle. I have enough information here to actually find the angle. Okay? Now watch this. I've got theta here. I want to find the angle, angle. Over here I put alpha. Oh. Why? Why another symbol? Why didn't I just put theta? Yes?
Because theta is both.
Because theta is the whole shebang-a-bang here. And I can't say over here, oh, theta will be, and I'll find out that it's 10. But then I have to double it. I can't say theta equals 10 and then theta equals 20. That's just no good. Opposite over hypotenuse. So we have got this, hello?
Could you put half theta, or is that...
You could put half theta if you wanted to. Opposite over hypotenuse, we know by now it's sine. Once again, we write our rule. We put our information in. I hope I'm not wrong, but I think it's from this you guys are quite happy. You could then do it. It's just getting the info. Is that correct? I see some people not writing this. Oops, and I put, so sine alpha equals 4/5. And therefore, to get alpha, to get rid of the sine, we have to take the inverse of sine. You can do that, and don't forget that theta is going to be 2 lots of alpha. when you use your calculator too, I would not put a decimal answer for alpha. I would actually, in fact, yeah, I'll do that now. I would not write anything here. I would just say that theta then equals 2 times sine to the minus 1 of 4/5. So I'm not rounding off my answer and then timesing it by 2 again. Try and use your calc once. Okay, a rhombus. I'd like to think that we all know what a rhombus is, pushed over square. And as we said at the start of the lesson, it was where do we find the right angle in a rhombus? And it is at the, it's at the diagonals. Where the diagonals intersect, that's where we get our right angle. And now let's pop our information on. A rhombus has sides of length 10. So where am I going to put that 10? The side. Thank you. So I guess in relation to the triangles, it's the hypotenuse. Would we agree? You do not have to write all the 10s there. I was just putting it in. And the angle between two adjacent sides is 76. Find the length of the longer diagonal. Okay, so you've got a choice to make here. The angle between two adjacent sides, so two sides that are next to each other. We can either make this the 76 or we can make this the 76. What do you want to go for?
The smaller one.
That's right, it's the acute angle. Okay, so this angle here is 76. We want to find the length of the longer diagonal. So obviously it's not that one, is it? It's that one, so we'll put our X there. So again, white noise. Goodbye, white noise. I've got that. That's 10. This is what I want. Ooh, 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 honey. That's the one that I want. What's my angle?
76.
Ooh.
Why is it not 76?
Look at my diagram.
38. Taking it in half. It's going to be half.
That there, it's the angle between the two sides. So it's half. And that's one of the things of a rhombus. That splits it in half. Finish that yourself. However, just a warning, people will find X, look at the answer and say, oh, I'm wrong. Because you need to double it. Correct. You want the one of the longest, so don't forget to double. So let's face facts. A lot of these questions, once you've got the triangle, it's quite simple. So you've got to look for some of those other little bits and pieces, like the units that we talked about last lesson, you know, kilometers, meters. Look and just be careful. We good with that? So, yep. If you're going, my brain hurts because it's all words, it's a lot of dots in there, it's got the word bisector. Now just break it down into small little bits. So in triangle ABC, yep, we've got that. The angle bisector at A. So all that means is this line coming down here, these two angles are going to be equal. They're equal. That's what the bisector means. Are we happy with that? Bonjour.
I was confused because what I thought if the two angles were the same.
Question, if the two angles were the same at the top.
Should be in the middle. But
So, right, so we're trying, that you're saying if they were the same, if these angles were the same here, then shouldn't these lengths be the same? Well, I guess we're about to find out and go, well, are they? We're either going to prove that they are or we're going to prove that they're not. So how are we going to do that? So is X the midpoint of BC? Hello. So is X the midpoint of it? How would we know if it's the midpoint or not?
wouldn't we break it down? And
Break it down, break it
figure
down,
out
break it down
the
then.
right angle triangle and then the other one?
Yes.
Because we have the angle of the other one.
Do we? We could find it. So as Grace has said, couldn't we find that? Well, yes, we can. Because if we can do two things, right? We can work out that whole angle because, as Grace is saying, you've got a length. So we've got adjacent and hypotenuse. So everybody can work out that whole angle. Do we agree, Matildes? Yes? Can you work out the length of BC without using trigonometry? You should be nodding your head. Pythag, correct. So you could work out BC by using Pythag. You can work out this angle by using trig. That's okay. How do we know, or how do we show if x is the midpoint or not? Got one person. 2, 3, 4. I could throw the mic to you, but you might miss it.
You could work out how long each side of x is.
Could I, how do you, when you say, I could work out each side of x, I'm pretty confident I could get bx. And you're assuming then I could get xc because I can subtract them. Yeah, but I could not work out xc before I did bx because that's not a right angle triangle. So you are going to do a couple of these things when I stop talking. 1, you're going to work out this angle. Now watch what I'm writing. You're going to work out angle BAC. Because I don't want to write a sentence. Work out angle BAC. Angle BAC. Correct? 2, and trig. You're going to work out the length of BC. Now you could use trig or you could use Pythag. I would prefer that you use Pythag because you're not going to use any rounded answers. You've got the information that the question actually gave you, so that's going to make you more accurate. That's the A+ student. Then you're going to find BX. And that would be, you would have to use trig because you now have this angle from part 1. Agreed? So this was just 3 questions lobbed into one. But I'm more interested in how you're breaking this up and going, okay, what can I do? What are some of the things that I could find? And even if you didn't know what to do, you go, well, I've got 2 lengths. Well, let's find another one. I can use Pythag at least. Where could I use trigonometry? Oh yeah, I could get this angle, and hopefully you would then progress. Tip, I'm circling back to you, Carolyn, so just keep that question. Bit of a tip on how to approach these. In isosceles triangle, the equal sides are 2/3 the length of the base. Determine the measure of the base angles. Oh, hell's bells. In an isosceles triangle, the equal sides are 2/3 the length of the base. So here's my isosceles triangle. Do we agree? I've got my base. It's all about the base, Then you've got options. You have got options here. You could actually come up, I'm killing the international student, you could come up with an actual value for the base. It's falling asleep on me. Okay, so if you wanted to, you could go 6. That's your base. What's 2/3 of 6? And by the way, you'll see why I chose 6. I could have chosen 6 or 9 or, right? So 2/3 of 6 is indeed 4. Determine the measure of the base angles. So we're finding theta. To keep it interesting, what we could do is now go, instead of it being 6, let's go 15. Hang in there, Grace. 15. Hey? No, stay. I wouldn't choose 10. Because to find 2/3 of 10, then it's going to be 20/3. It's not a nice number, right? So that's why I go get lost, horrible, and a horribilis, and a 15, because 3 goes into 15 5 times, so that means that's 10. Yes? You could do this. Someone else could do this one. If you're really wanting to strain the brain, you could do, don't write this down yet, you could do x, and this would then be 2/3 x, or if you called that 3x, what would that be? X. Right? My suggestion to you is this will work just with basic numbers. And it's going to be easier for us today because remember, you have to halve that, so this would actually be 3. Yep, and you're doing sensible. You can do it to prove generally it works with X, whatever, but trust me, you've got similar triangles here and they're all in the same ratio. So it's a bit of a question, people. So I need everybody, Matildes, to actually pay attention. And you can go back and finish time with your right angle if I can get this done. So non-right angle trig. With right angle, we had to know really carefully how we labelled our triangles. Opposite, adjacent, hypotenuse, correct? With right angle, non-right angle trig. So there's no right angle here. So be careful with the spelling now. This angle here, not only are we going to label the angles, we're also going to label the lengths, right? So this angle here, let me spell it right. This is called capital A. This angle here is called capital B. And this angle here, capital C. Everybody make sure you get the spelling right.
A, B, and C.
The length that is opposite angle A is little a. Look. The length that is opposite angle B is little b. And the length that is opposite angle C is P.
What?
That's right, little c. Little c. Now, I promise you this, you will not have to actually label these triangles. Twiggy, I can see, right? So I've asked you to be paying attention, not drawing on someone else's. And this is now on video. You are only going to be using this A, B, C thing so you know what the rules are. And there are 3 that we're going to look at. You can see them on the poster over there. We've got the area, the sine rule, and then the cosine rule. All right? So we're going to start with our area formula. So it's up to you how you want to set this out. I do have beautiful examples in our OneNote. We will have 3 different types of questions for area. 1, straight plug in. Here's the lengths, here's the angle, plug it in, find the area. It might be that you are given the area, 1 length and the angle, and you have to work backwards. But Bryn, everything is, you'll see in a minute, everything is times, times, times. How do we get rid of timeses? That's the extent of the maths you're going to do. The other situation will be, again, I give you the area, I give you the 2 lengths, and you have to work out the angle. Well, we already know how to get rid of a sine, inverse sine. So, the formula that you're all hanging out to see. Area, and this is a non-right angle triangle, right? We know to find the area of a normal triangle, we need the base and we need the vertical height. What's going on here is you're not going to have that vertical height. But lucky for us, we will be able to say it's a half AB sine C. Now, I could write that in another 2 different ways. The key to it is that, not the eraser, the key to it is I've got A, I've got B, and I've got my angle in the middle. So as we just saw from Ross, I need 2 lengths and the angle in the middle. I change it a little bit. Elbows, right? 2 lengths, angle in the middle. That's how we know we've got enough information to go the area formula. Okay, with you, we are going to skip a whole lot of these questions because, look at it, we've got 2 lengths, we've got the angle in the middle. You go a half times the 2 lengths times sine of the angle. Bang, we're done. All you got to remember is put centimetres squared at the end. Or, God forbid, metres squared. Same with question 1. Look at it. 2 lengths, angle in the middle. Do we have to do these? If you want to, you can, but you'll see in a moment you will be doing them just a little bit different, right? Zoop, zoop. So again, half times this times sine 82, half times this. The only thing you have to watch out for is if I had this 17, 30, and 50, you don't go, oh yeah, there's two lengths, a half times 17 times 30 times sine 50. What you should do for this question is what, Grace?
I have no idea.
No, you're just doing that. You're doing that. What should we do?
Have to find the length of that.
No, we go, cannot do.
Oh.
Because we need the two lengths with the angle in the middle.
Then what do you do if you get a question like that?
For now, you would go, cannot be done.
Oh.
When we get a little bit more skilled, we can answer those questions, right? So, everyone got that down? Here we go. And I'm going to show you what I have on OneNote shortly that you can look at that will help you. I can't show that on the video because your names come up, so yeah. I don't want to have people's names there. Oh, well, you know, I try. Draw the triangles if you don't want to, but obviously it's going to help you if you go back and have a look. Hello?
So the two sides with the angle.
Yep.
That is to find the area.
Yep.
Okay.
So all they're checking on you doing here is picking which, can you pick which lengths wrap around the angle? I know. Which ones is it?
13 and 7.
13 and 7, exactly. So if you want to, you know, I can get my little highlighter thing out just so I can be specky. But here we go. Now, area, I like to write the formula because, I don't know, just makes me look like I'm doing a heap of work when really I'm not. Right, does it matter if you call 13A or B? Does it? No. So no labelling of our triangle. You just are saying you're using that to find the rule. So times 13 times 7 times sine 66, and to the calculator, you are done here. We're just doing area at the moment. Just focus on this. So my friend, mystery student, you just made a comment about B.
Yes, I did.
Could you share that comment with us?
B, they're trying to trick you, but it's actually pretty easy because they don't show you the angle that you need, but you can figure it out because a triangle is made up of angles adding up to 180 degrees, so you can use the other two to figure out how much more you need.
I love you in a professional manner. Thank you. Right, so that was sensational. Loved it. So this angle here is going to be 180 minus 53 minus 31. And then, once you've got that, huzzah, you've got the two lengths that surround the angle. So it's making sure that you're paying attention and you're not just going, oh yeah, two lengths, I'll just eeny, meeny, miny, mo on those angles. I'll just choose any one. Not allowed to do that. Does that make sense? Can we have a volunteer from the crowd to suggest how go on, Hamish loves it. Sorry. How we're going to do C. Sweet. Do you want to hold this and
Okay. Hello.
mystery word?
The line there is the same, so that's also 5 there. And then because it's isosceles, correct?
Yep.
This angle is also the same. So then we can add those two together. To equal 142. And then 180. Take 142. Oh, whoops. And then
Away you go.
yeah. And then you got the wraparound.
Legend.
Sweet.
Legend. Thank you, mystery student.